This is Physics for Grade 11, produced by Tigray Education Bureau, transmitted by Dimtsi Weyane Tigray National and FM radio satellites and social media, and also FM Maqala 104.4.
Hello, students. This is a physics lesson prepared to grade 11 and presented by Weyane. Welcome to today's lesson of rotational motion. Students, in our last lessons, we learned about work, energy, and power. In addition to this, I hope you have discussed the relationship among work, energy, and power, as work is a way of transferring energy from one form to another. Energy is the ability to do work, and power is the rate of doing work, or power is the rate at which energy is being supplied or converted. Today, we are going to discuss a new chapter, that is Chapter 6, which deals about rotational motion. Under this unit, we will see angular displacement, angular velocity, and angular acceleration. Students, be ready and let's begin. Students, before rotational motion, let us define the term motion. I think that you are familiar with the term motion from your previous grades. Motion is the change in direction and position of a moving body. In other words, motion is the movement of a body from one place to another place, or from one point to another point. Good. Now, let's define rotational motion. Rotational motion is the motion of a body that takes place in a circular path about a fixed axis. Here, a fixed axis implies that an axis of rotation where a body rotates around. The axis of rotation may be towards x-axis, y-axis, or z-axis. Students, let us do an activity. Write down some examples of rotational motion. Welcome back, students. Here are some examples of rotational motion. 1. rotation of the Earth on its axis, which creates the cycle of day and night. 2. Rotation of wheels in a vehicle, which creates vehicular motion. 3. Rotation of modern machines, such as gears. Students, having this in your mind, let us see the 3 concepts in rotational motion. The first concept of rotational motion is angular displacement. Angular displacement is the angle through which a body has rotated. In addition to this, angular displacement is the central angle formed while a body rotates about a circular path of radius r. We can also say that angular displacement is the ratio of tangential displacement or arc length to the radius of the circle. That is, angular displacement is equal to tangential displacement divided by radius of the circle. Its SI unit is radian, but it can also be measured through revolution, degree, and cycle. The relationship among those units is described as 1 revolution is equal to 2 pi radian, and 1 revolution is equal to 360 degree. This means that 2 pi radian is equal to 360 degree. Therefore, we can solve problems related on angular displacement either in radian, revolution, or degree by using the above relationship. This means that by converting radian into revolution or degree and revolution into degree or vice versa. The second concept of rotational motion is angular velocity. Angular velocity is the rate of change of angular displacement. That is, angular velocity is equal to final angular displacement minus initial angular displacement divided by time taken. And its SI unit is rad per second. In addition to this, angular velocity describes how fast a body is rotating. This implies that angular velocity has a direction along the direction of angular displacement. Due to this reason, angular velocity can be positive, negative, or zero. Students, here is another activity. When does angular velocity be positive, negative, or zero? I hope you all have answered the question. Good. Let us do it together. Angular velocity can be positive if the change in angular displacement increases. Implies that if final angular displacement is greater than initial angular displacement, and this is lastly reduced to angular velocity will have the same direction as angular displacement. Angular velocity can be negative if the change in angular displacement decreases. Implies that if initial angular displacement is greater than final angular displacement. And again, this is reduced to angular velocity will have opposite direction to angular displacement. And again, angular velocity can also be 0 if there is no change in angular displacement. Implies that if initial angular displacement is equal to final angular displacement. Good, students. Now, let us proceed to the third concept of rotational motion. Angular acceleration. Angular acceleration is the rate at which angular velocity of a body changes with time. Or angular acceleration is the rate of change of angular velocity. That is, angular acceleration is equal to final angular velocity minus initial angular velocity divided by time taken. Its SI unit is rad per second square. Students, this is a time to do search activity. Can we say the direction of angular acceleration is dependent on angular velocity? Why? Welcome back, students. If you say yes, you are correct. Because as the change in angular velocity increases, angular acceleration also increases. This implies that the direction of angular acceleration is the same as that of angular velocity. And as the change in angular velocity decreases, angular acceleration also decreases. Implies that angular acceleration has a direction opposite to angular velocity. Students, here is the last activity of this lesson. What do you think about the directions of change in angular displacement, angular velocity, and angular acceleration? Good, students. Let us do it together. The change of the three quantities implies that angular displacement, angular velocity, and angular acceleration is the same. That is, it lays on the same rotational axis. Good, students. Now it's time to conclude our lesson. Today, we have learned about rotational motion, angular displacement, angular velocity, and angular acceleration. I hope you are delighted with the lesson. In the next time, we will learn about torque, rotational inertia, rotational kinetic energy, and parallel axis theorem. Mind you, students, take this as a reading assignment and do exercises inside it up to the end of this chapter. Thank you, students. Until next time, goodbye.